Hello everyone. Today we'll discuss about recovery scheme based on shadow paging. Now, shadow paging is a recovery mechanism in DBMS which will maintain or ensure integrity and consistency without requiring extensive logging. Now what it does, or what is the basic concept is, it maintains two versions of the database pages called as current page and shadow page. Current page where it is being actively modified, and shadow page is the current represent the stable consistent state of the database. That is, you are keeping a copy where you are making the changes. The original is a stable copy which I call it as a shadow page. What is the working, or how does it goes at? Now, in a shadow paging, the database is divided into two fixed size blocks or pages called as current and shadow page. It maintains two page tables also, which are called as current page table CPT or shadow page table SPT. Okay. Now, like I can just talk about a situation. There will be two pages maintained. This is your CPT, which will contain, let me say, P2, P4, P1, like this, different pages which it is accessing, and SPT also will have P2, P4 and P1. Okay. The idea here is, first initialization, both CPT and SPT are going to be same, identical, because a copy is maintained. The changes will be made into this, original will be as it is, stable. So both of them are going to be the same. So SPT is written to a non-volatile storage media so that I can ensure its existence, or it is not lost even at system failures. Now whenever a transaction begins, so any modification to a page results in a creation of a new version of that page, and that will be maintained by only CPT. The original page remains unchanged, preserving the pre-transaction state. So page modifications are done only into CPT. So when a transaction modifies a page, the DBMS creates a copy of that page. Now let me say P4 is being modified. So there is a copy of it, and CPT will point to that copy instead of the original copy. The CPT is updated to point to the new version of the page, while the SPT continues to point to the old version, that is not modified, it is as it is. Now let us see what happens. Whenever a commit operation has to happen, when the transaction commits, remember whatever changes you are doing it to this particular page, and CPT, current page table, is pointing to that. Now it is updated to that. Okay. So operations are done, everything was successful, a commit is written. So when the transaction commit, the CPT is written to the non-volatile storage. That means the updated page is going to be written onto the database, and at this point the SPT can be updated to match CPT. That means making the new page versions the new stable state. So that is going to be, that means when you are updating, the SPT can be matching again with the CPT if it is committed. Whereas if it is not, if the transaction fails, then we want a rollback operation. So if a transaction needs to be rolled back, the DBMS simply discards the modified pages of CPT. The SPT remains unchanged and database reverts to its pre-transaction state. Look at this. So if it commits, then this page, new page, will be updated onto the database, and this will also have to point to this new page. Anyway, it is updated, so now we don't have the work on SPT and CPT, but SPT needs to be used for the next transaction. That is why I will ensure that it is updated. What about rollback? In a situation of rollback, don't write this at all. This page changes, I don't want it all, it has to be neglected, so just depend upon this. So you don't write it onto the database. That is what is the rollback operation. Now what is the advantage of using this shadow paging? There is no undo logging required, because since the original pages are never overwritten, there is no need to maintain the undo logs. Copy is there as it is. Whatever changes you were making to a temporary page. So page modifications are done only there. So if the transaction has to be aborted, you just don't have to do anything, just discard this. Consistency, database remains in a consistent state because shadow page represents a stable snapshot always. Okay. Simple rollback. So rolling back, when you have to say, you need not have to again undo the changes and all those stuffs are not there, just discard. It's straightforward. It simply involves discarding the current page and reverting to the shadow page. So based on your log record, whatever you have done a equal to a minus 50 and it was updated, now you again have to do a equal to a plus 50 and see to that it will revert back to the original value. All those things are not there at all. So it's just discard that. What will be the disadvantage? There is a copy overhead. Every time you need to change a page, you have to have a duplicate copy of it. See, page modification requires copying a page. This will be resource intensive because you are utilizing so much of resource. Space utilization. See, maintaining 2 versions of the page can lead to higher storage requirement. Again, whatever I told, resource intensive. Memory is also a resource. Okay. Coming to this checkpointing complexity. Periodically updating the SPT to match the CPT can be complex and time consuming, especially for large databases. Because in case of large databases, you have several table updations, several tables involved. So all those tables are distributed across multiple pages. So page table and the current page table and stable page table itself occupies a lot of space, and every time you need to keep updating them. Every time you need to make the modification, that itself may be time consuming. So anyways, this is one of the options or one of the methods of recovery in case of DBMS. So we have seen 2 methods, log based recovery and shadow paging recovery. Now what actions has to be taken or what specific information has to be kept in mind and changes has to be done in case of recovery in a concurrent transactions, we'll see in our next lecture. Thank you.